Hi everyone, it's Miss Hacker bringing you chemistry live from my apartment. You might notice my assistant cat is here. His name is Frodo. So if he pops into the videos from time to time, I'm so sorry. So I hope everyone is doing well during this time of quarantine. I hope you're finding ways to keep yourself busy. And now that we're going to be posting more material, hopefully this can help curb your boredom. Well, if you'll remember before spring break, we left off with the gas laws unit, my favorite unit. But I took all of your packets because I didn't want you to do homework over spring break. And it would now seem that was a poor decision because I don't know how you'll ever get those back. So I thought, since it's been a little while since we've talked about any of this material, I would just do a very quick refresher. And I like to do refreshers in the form of demonstrations. So I have a little something for you. And I'll have to move this closer. Let's see, can we make this work? Yes, we can. So let me move this closer to you so you'll be able to see what's going on. Let me grab my materials. We have water. A small beaker. Half of a Petri dish. Candle. 2 pennies. And you're probably wondering, what could this possibly have to do with gas laws? Well, we know that there are gases all around us, and the one we're going to be working with is air. So I'm going to take my Petri dish, half of a Petri dish. I'm going to place these pennies in the Petri dish on either side. Hopefully you can still see this. I think you can. Okay. Now I'm going to add just a little bit of water to my Petri dish. Okay, that's good. So the pennies are covered and we don't need that anymore. Then I'm going to place my candle on top of the pennies. And the next step, I don't know, this might be too much water. I think we're about to make a mess. I'm going to pour some of it back. Okay, that's better. Now there's the candle. Okay, and the candle is now lit. So I'm going to let this burn for just a moment and let's think about what's happening. So as this candle is burning, we know that heat energy is being produced. So we're going to use the term energy in just a moment, and we're going to relate that back to the things we've talked about already, to temperature, pressure, the number of particles of a gas, and volume. Okay, so this has been burning for a moment. I'm going to take this beaker, I'm going to turn it upside down, and I'm going to put it over this candle. So watch very carefully to see what happens. Okay. Did you see it? So my candle is currently stuck in here. Pretty far, actually. Can you see that? Okay, let's do it one more time, just in case you did not see. It's lit. We'll let it burn for just a moment. Okay, again, watch very carefully. Watch where the candle starts and watch where it ends. Oh wow, that one went really far up. Okay, So that candle was sitting on top of those pennies, and now, wow, now that's really far into the beaker. Okay, so what just happened? How can we use the gas laws to explain what just happened? Well, I'm going to go ahead and share my screen with you. And let's look at what's going on. Okay. So, we don't want during. We want before. Sorry, guys, this is a learning curve for me too. Okay, here we go. This is what we want to see. And let's share with you now. Okay, so before, this is what we saw. You see a candle and it's burning. So that flame means that there's an increase in energy happening to the air surrounding the flame. During, so when I place this container, this beaker, over the flame, we still have the air inside of this beaker being heated. And remember, increasing the temperature increases the energy of a gas particle. And that is the only way to increase the energy, is by increasing the temperature. So the energy of the gas particles in here is increasing very, very quickly because it's being heated. But what happens the moment the flame goes out? Well, when the flame goes out, the temperature inside of this beaker cools down rapidly. And as it's cooling down, the gas particles in here are also decreasing in temperature, which means their energy is decreasing very, very quickly. When these gas particles are trapped inside of a container and their energy is decreasing very quickly, so we have an extreme change. It goes from a high temperature with a lot of energy to a low temperature with very little energy. We see, first of all, that the flame went out. Well, that makes sense because there was no more oxygen in this. All of that oxygen was used up and it's gone. So all we had was carbon dioxide, and we need more than carbon dioxide in order to keep a flame burning. So no flame means no more energy being added. So we have our decrease in energy. Well, as soon as that energy decreases, it creates a sort of vacuum inside of the beaker, and it sucked the candle up to this level. So that's why we saw that candle pushed up in here and it actually stayed. I'm trying it now and it's not staying. So, quick recap. When the candle was lit, it was increasing the temperature of the air particles, and according to the kinetic molecular theory of gases, when the energy of gas particles increases, that is caused only by increasing the temperature of those gases. We cannot change it in any other way. So we increase the energy of the gas particles. And then, as this energy is increasing, we're going to focus only on the air that's inside of this container right here. It increases and then immediately decreases, creating this vacuum. So now the candle is stuck inside. And there you have it. So I explained this demo, but the next video I will be posting, I will be performing a second demonstration and you will be explaining what's happening. So you're going to think about the science behind the next demonstration. So for now, from myself and Frodo,
we will see y'all later. Have a good day.